the addition of orders before with other graphs, and it's the same process. Don't forget, we're adding the Y values together. So I've mentioned in the past, what's that, blue and red? So we'll go with the green total. We're adding the Y value. So there's a few absolutely must values you must get right. Where one of the graphs cuts the x-axis, its Y value is 0, which means if I add the blue and the red line together, it has to go through there. The blue line is 0 there, which means if I add it to the red line, it has to go through there. Whereas the blue line is 0 there, it has to go through there. Red line is 0 at pi, so it has to go through the blue line because the 2 of the blue plus 0 of the red gives me just 2. The blue line is 0 there, which means it's going through there, the corresponding red line. Blue line is 0 here, which means it's going through that red line there. The red line at 2 pi is 0, which means it has to go there. All right. Now, the only other place that I think is reasonable to try to get accurate is where the two lines intersect, because where they intersect, we know that the value is twice that size. So you can see here that with this scale, it's sort of 1 and a bit. You'd almost argue it's 1.25. Two of them takes it up to about 2.5, so maybe it goes through about there. Okay, same spot. Okay, because a bit of symmetry, so it might go through about there. Where else do they intersect? Just out of sight. And then you're just looking for any other values where they might coincide. Now, in an exam situation, boys, you'd be given a pretty good scale. So we can see here the red line's at 3, the blue line's at -2. So if I add those together, I get +1. Yeah. Down here at 3 pi on 2, one of them is -2, the other is -3, so it should come down to -5. All right. And so from there, it was just sort of sketching the points together. Now, is the turning point higher than that? Possibly. You know, it's hard to know where the maximum is, but it could come up that way. So we just do your best. To there, we obviously must come back up. Is that the turning point? Well, in this case, probably it is because of the nature of the two graphs. Come up, go to there, where I've got a, well, again, I guess we could try to find our intercept exactly. Somewhere between this graph and this graph, they're going to be equal, so it's going to go through somewhere. And we can see it comes down to -5, and then we must come up. Now, is that a turning point there? Possibly, but given the periodic nature of our graph, probably not. Probably comes around like that. Okay, we had to sketch between 0 and 2 pi, so we'd have stopped there anyway. So let me just rub out the bits and pieces that I sort of added, just so it's not quite as confusing. And we'll stop at 2 pi. Okay, so look, the addition of ordinates, it's going to be the process by which we try to sketch an unfamiliar graph by sketching the two components of familiar graphs. Okay, if by chance you had to do it in a tech-free environment, try to draw the two individual graphs you've got as accurately as possible. Use a nice scale, God's sake, use rulers, and then work through. Questions in 6H, look, do a couple of them. Obviously, forgot to put them down. So a few questions from 6H there, just to practice that process with the tree graphs.